Hi, this is Donna Warren from the University of Wisconsin-Stevens Point, and today I would like to talk about how argument mapping can help us to identify and supply missing conclusions in an argument. We've seen that argument mapping can give us diagrams of fairly complicated reasoning, like this, out of just a few, literally a few, relationships between ideas. First, we have this arrow relationship, then we have this plus relationship, and finally we have this independent reason type relationship. Now, suppose that we are reading an argument or someone is speaking an argument to us. More often we would be reading. And suppose that the author doesn't say all of these ideas. Suppose in particular the author leaves this idea out. She does not state that, well, what would that be? That would be a subconclusion, right? It's not the ultimate conclusion. It's not a premise. It's a subconclusion. Suppose she doesn't state that subconclusion. That, if we don't supply the missing subconclusion on our own as we read, the absence of that subconclusion can really make it hard for us to understand the argument. Can you see why? It's because we might follow this all the way down. We might, see that she has two ideas here, but if we don't somehow supply this idea, fill it in, we are not going to understand how any of this bears upon this. The reasoning will be short-circuited, essentially, by that unstated subconclusion. It doesn't need to be that way, though. Subconclusions or even ultimate conclusions can be fairly easy to supply if they're unstated once we kind of get the hang of it. So to work our way up there, I want us to sort of warm up with an arithmetic problem. Add those numbers and do it mentally. Don't use a calculator. Just do it in your head. Okay? 3 plus 5 plus 7 plus 1 is, drum roll, 16. Now, what I want you to think about is how you added those ideas to come up with 16. I do this in class a lot, and when I ask students how they come up with the sum, I get interestingly different answers. Some people say they do what I frankly would do. I always try to go for tens, so first I would add the 3 and the 7. That would give me 10. Then I would add the 5 and the 1. That would give me 6. And then I would add the 6 to the 10, and that would give me 16. Sometimes people will say they'd add the 3 and the 5 first to give them an 8. Then they would see that, well, the 7 and the 1 rather is another 8, and then they would add the two 8s together to get 16. Some people say they would add them two at a time, just moving straight on along. So they would say the 3 and the 5 would be an 8, plus 7 would be 15, plus 1 would be 16. Then I ask, did any of you just add up all those four ideas together at once? So that if I were to ask you what two ideas you added first, you would say, what do you mean, what two ideas did I add first? I just added the four numbers. I have yet to find anyone who admits, at least, to just kind of swallowing this thing whole and adding the four ideas at once. Why not? Well, because I think that most brains don't work that way. Most brains put things together two at a time, whether those things are numbers or whether those things are ideas. So here's the general strategy. We are always going to try to keep in our mind only two ideas at a time. If you're trying to hold together three ideas at a time, you're thinking maybe too hard. So just two at a time. So when we're reading, mostly reading, because it's easier, when someone talks to you, the ideas are there and they're gone. So I'm just going to suppose that we're reading. We're going to keep two ideas in our mind at a time. As soon as we have those two ideas, we'll ask ourselves, how are they related to each other? Are they related to each other as a premise or a reason and a conclusion? Are they related to each other as dependent reasons? Or are they related to each other as independent reasons like this? If two ideas are related to each other as dependent reasons, we'll ask ourselves what follows from those two things once they're added together. If that idea that follows from the two ideas that we added together is stated later on, great, we know exactly where it goes in the argument, right? It'll go right underneath with an arrow, those two ideas. But if it's not stated, that's not a problem. We'll just add it in. We'll supply it on our own. And we can use the puzzle piece test to do that quite nicely. For instance, suppose we have two ideas like this that are added. They hook together at the circles. The idea that's joined, or the idea that follows from those, will be the idea that's composed out of the non-common bits, like this, right? So we can use the puzzle piece test 9 times out of 10 to figure out what the subconclusion is, and then we continue reading in the same way. We read along, we get another idea, now we have two ideas in our head, we ask ourselves, how are those two ideas related? With an arrow, with a plus, or separately? And if it's related with a plus, well then we figure out what follows from that, and we add it if we need to, and we sort of like rinse and repeat. Got it? So, let's do this. Here are 3 ideas. You'll probably be seeing quite a bit of Max, so you might want to get used to him. Max is a poodle. Max is a poodle. Poodles are dogs. Dogs are adorable. That's 3 ideas. That's too many. Let's see which 2 ideas we might want to put together. Remember, we add things together 2 at a time, not 3 at a time. Now, we could, if we wanted to, put together dogs are adorable with poodles are dogs because they have something in common. They have dogs, right? So there's that circle join. We can join them there. I, however, am going to put together Max is a poodle with poodles are dogs because, as a general rule, I prefer to add ideas together as I encounter them. It's just a slightly smoother process. So let's do that. We're going to add together because it seems to me that Max is a poodle and poodles or dogs are in fact related with a plus. And now if we ask ourselves what follows from those ideas, well, Max is a poodle, poodles are dogs. They join together at the common concept of poodle, and what we have then is Max is a dog. Now, because we added that, I'm going to use a different color post-it. This is getting now very advanced. And I am putting that sentence in square brackets too, just in case you can't see the color for whatever reason. It'll signal that we added that. Now, these 2 ideas are essentially done. We've used them. This idea now, though, is an idea that we haven't have in our mind. This idea also we still have to use. So how do you suppose dogs are adorable and Max is a dog should be related to each other? With an arrow, with a plus, or with separate arrows? Seems to me that they are related again with the plus. They should be added. So I will do that. Now I'll have to move dogs are adorable down, but that's fine. So Max is a dog. Dogs are adorable. They join together at dogs. What we have then has to be composed out of Max and being adorable, which luckily for Max gives us Max is adorable, like that. Not too bad. Now, there's something I want to stress here. Adding these missing conclusions helps us to understand the argument as it is being presented to us. It doesn't help us to evaluate it. So the mere fact that an idea seems to follow from 2 others with the puzzle piece method does not mean that this inference is good. That's actually okay because this is a technique that helps us to understand how someone is reasoning. It's not a technique to evaluate. We'll get some of those later. So for an example of how that can happen, suppose we have another argument, or not argument, I guess, 3 ideas. Hank is not a poodle. So Max is, but Hank is not. Hank is not a poodle. Poodles are dogs. Only dogs are allowed inside. Let's add this again. Hank is not a poodle. Poodles are dogs. Now let's use the puzzle piece test to figure out what follows from these ideas, because I do think that they should be added, not arrowed, not separate. Well, what do they have in common? Poodles. What's left over here? Hank is not. What's left over here? Dog. So if we use the puzzle piece test, adding these things, like so, what we would get is Hank is not a dog. Okay, that's one idea. What about this over here now? Only dogs are allowed inside. Well, it seems to me that that should be added to Hank is not a dog, again. So I will add that, moving this down. And Hank is not a dog. Only dogs are allowed inside. It would follow from that that Hank is not allowed inside, using the puzzle piece method. Because what's in common between this idea, only dogs are allowed inside, Hank is not a dog, is basically dogs. What's left over here? Hank is not. What's left over here? Allowed inside. Hank is not allowed inside. Now, this inference is actually pretty good. This is a fine inference down here. The inference up here is not. I hope I'm not making you seasick by moving this around so much. This inference is actually not good. This is a bad inference, but that's okay. The puzzle piece method doesn't tell us whether the inference is good. It just helps us to see probably what the inference is, what the author of the argument supposes would follow from these. Lots of arguments, alas, are bad, and this is one of those. So there you have it. That's a fairly advanced technique, adding missing subconclusions, but I hope it makes some sense to you. It's really handy, helps you to understand a lot of things if the author or the speaker leaves stuff out, as authors and speakers inevitably do. So I hope that made some sense to you. I hope you enjoyed it. I did. I like this stuff. Bye-bye.